All right, cool. Hey, all right. So yeah, I'm Adam Baldwin. I'm a security wombat at NPM, the VP of Security, and I get the pleasure of trying to secure the world's largest package ecosystem. My first contribution to open source was 7 years ago, and it was actually to the NPM registry. This is kind of happenstance. My first pull request was to fix a cross-site scripting vulnerability in the registry, and that was before it was a company, before it was VC backed. And shortly after that, I started the Node Security Project, and this was to bring security as a core value to the Node ecosystem, right? It was very early on. It's like Node 0.2 days, and no one was doing anything with security in Node. I'd show up at developer events and talk and meet people, and no one knew what pen testing was, clicking pens. Like, they didn't know what application security wasn't a thing. And so we were just trying to promote the OS top 10 and talk about security and to make it better. And along that journey, we made a database of vulnerabilities, and we built some tooling to look through packages, and that's kind of where we sat. This was 6 years ago, and it hasn't changed much since. About a year ago, my company at Lyft Security got acquired by NPM, and this was NPM's strategy to move beyond being a bit store, right, an archive store, and to become the tooling that the ecosystem needs, right, the compliance tooling, the security tooling. And yeah, I often said when I first started the Node Security Project, the best way to own the registry was to get a job at NPM after the company was established, and this happened eventually, so that was kind of fun. So my agenda today is to really help everyone here understand what NPM and what that sort of dependency, that supply chain risk is, to understand what our security challenges are, and understand what we're doing to help build confidence in the registry and in that ecosystem, even though it's not perfect. And then kind of talk about what the future looks like there and what we're doing. So what the hell is this NPM thing anyway? It is the Node. It is bundled with Node originally to bring in JavaScript packages, right? People think it stands for Node Package Manager. It just has no particular meaning. It is actually not Node Package Manager. But for most developers, it's a CLI. They run this command and they bring in a dependency, right? They bring in some piece of code so that they can stitch it together, so they can dev really, really fast. They can be efficient. This is what a typical application looks like. We have our sort of like, and this is what a typical Node package looks like, as well as an application. You have your code at the top, right? You have dependencies, and this is kind of n levels deep. And you think about it like an iceberg. The developer knows, again, as was said earlier, I think Michael, the developer knows about, say, Mocha or Helmet or Express or whatever. They don't know about the rest of this iceberg underneath. They don't really care about that. And you have, again, another layer that doesn't get really talked about much, and that's the maintainers underneath. This is all foundation on humans, right? Maintainers. 97% of modern web applications, and this is being generous, are third-party code. You're bringing in code, so you're shipping code to production. The majority of the people writing code that you're shipping to production are not employees. They aren't people you control. You have no control over it. What's interesting about this fact, 97% of this code, is that we did a survey in 2017, 2018 and 33,000 respondents. 83% of those people were concerned about the security of the open source code that they were bringing in, and 86% were concerned about the code that they write themselves. They were more concerned about the code that they're writing versus the code that they're bringing in, despite it being a very, very small percentage of the code that they're using. NPM is also a registry of packages. In fact, this slide is out of date. I updated it yesterday. There's now 963,000 packages in the registry. That is over, that number at the bottom is also wrong. It's right around 8 million individual package version combinations when you think about the scale. Individual combinations of things that you can have out there. We get 7,700 publishes a day. Publishes, new stuff in the registry, 2.1 billion downloads per day. 11 million developers consuming from the registry, and over 1 million of those are package maintainers. They're publishing code to the registry. That's the scale we're talking. Everyone is using JavaScript. And I don't care if you read the Montesano article from 2011 that says JavaScript crypto is bad and want to yell at me about how JavaScript is bad. Your developers are using JavaScript. It exists in your environment. It is running. It is something that you have to deal with and help enable happen. Governments, finance, fintech, in entertainment, political parties, foreign and domestic governments, they're using JavaScript. And NPM is the supplier of that JavaScript. And a hint, it's not just JavaScript. There's native code that is distributed, C, C++, that gets built when you download it. It may have pre-bit binaries or it may build, right? So you not only have to worry about the sort of the JavaScript flaws, but you also have to worry about sort of the native code flaws, classic buffer overflows, those kind of things. There's thousands of native modules that are in the registry. bcrypt, one of the most popular libraries, is a native module, depending on how it gets brought into your project. This is kind of what that flow of information looks like. I made it kind of asymmetric because it's kind of a wonky deal. You have a developer that's shipping code. This is kind of where you can see to get the feel for how you're going to take over the world by owning NPM. So you have a developer that's shipping code to GitHub, right? It goes to CI. It may CI publish to GitHub or to NPM. The developer's also pulling down packages from NPM to do their development. And then they may be shipping these things out to production, and it may go out to production. So you kind of see NPM is at the center of that circle. Not really a circle. So, all right, we've got, this is what kind of NPM is. Who's responsible for this? Who's responsible for securing the commons, right? It used to not be a VC-backed company. It used to be not a company you could buy goods and services from. So who's responsible for securing this? Many people say, well, NPM, but you are responsible for what you require, developers, enterprises. And Michael said it this morning, right? Like, you are responsible. The licenses say it. There's no warning, or there's no warranty. It's on you. 100%. The code that you put in your production is on you. You also have the responsibility of using tools correctly updating your dependencies, knowing what you're downloading, what you're installing. What's interesting about this is that, part of our survey here, what methods do you ensure the security of your code? If you're responsible for it, what are you doing? Code review is the biggest, the most sort of like used control. Scanning, who knows what. Audits, and then none. 23% of those 33 respondents are just doing nothing. Okay. As a package maintainer, they have the biggest burden when I was sort of looking at the list, right? Providing code that promises to do what it does. Providing secure code that, unless it's clearly stated, this is malware. Keeping explicit or implicit security promises, maintaining updated dependencies, and monitoring for malicious contributions. It may be just contributions to their GitHub that eventually get published as a package, right? There's a lot of responsibility for a maintainer. Guess what? They're volunteers. They're not paid. They burn out just like the rest of us. You've got NPM. What are we responsible for, right? We're a company, right? So there's somebody you can call and you can yell at. You can email support. You can email security@npmjs.com. We're responsible for delivering the packages as expected. Just like regular supply chain with a big container ship, they have a manifest. If you request bits, we should give you those bits. We're responsible for maintaining, removing malware. You tell us about some piece of malware, we're going to get rid of it. And, alerting users of known vulnerabilities. We have taken that node security data and we've given it to all of the users as part of our service. So let's talk about now some recent challenges. We'll tell a story, and you've heard some of these, I'm sure, or know of them. Event Stream was a very recent and very high-profile incident for us. Now, it didn't target NPM. In fact, it targeted one organization. That module has like millions of downloads a day. It targeted one company. copay. It involves social engineering. In fact, developer burnout is now attack surface. This particular developer, Dominic Tarr, had event stream, and after 5 years was done maintaining and was tired. So somebody came along and said, I'd love to maintain this. I use it. And so Dominic said, sure, come on in. And of course, they acted like a good actor. They updated some dependencies. They came in. And then all of a sudden, they kind of dropped this dependency that had a nice, encrypted payload in it. And that's how we ended up. So we got lucky with this one. It used an encrypted payload that decrypted based on the description of a project that you brought it into. Somebody happened to have cloned the copay app and published it to the registry. So when we did a brute force, we got lucky because the decryption key was in the registry, or we would have probably never been able to triage that as fast as we had. We had it decrypted in about a half an hour with a team of 4 people, and that was pretty fast. So that was a fun one. That was a case of social engineering. Here's another recent one, which is the ESLint scope. An attacker used credential stuffing, took over an account of a dependency. So ESLint scope was the module that was taken over, but it's part of a very popular linting framework. And again, millions of downloads. They took over an account, and they published a new version that stole NPM credentials. And it seemed like a sophisticated attacker, but their payload was garbage. It's like they didn't know JavaScript. It was very buggy or very untested. And so it didn't have the traction that it could have. And we burned down about all of the authentication tokens in the registry very, very quickly. We made that call just so it didn't have any way to propagate. So this is kind of the, you're thinking again about the sort of the attack tree that we have going on here. It's all about getting a package into the registry. It's all about, like, those packages are key, because anybody can just publish a package, right? You can just go publish foo, bar, whatever, but you have to get somebody to install it. And so that's where typo squatting came in. Michael did a great job of discussing that earlier. And we do have some trivial protections in place to do distance checking. Did you add .js to the end of it and it's related to a popular package? Yeah, we're not going to let you publish it. But the most impactful one is taking over an account, or getting added as a maintainer to an account, leads you to really impacting results. Of course, there is insider threat, and if you do happen to use something like Yarn, which proxies both the metadata as well as the tarballs, the organization that maintains the domain for that tool can modify either of those if they wanted to. So now you get to worry about insider threat at 2 organizations, Facebook and NPM, not just one. So that's that. So what are we doing to okay, that's kind of the doom and gloom. What are we doing to give you some sort of integrity, give you some sort of confidence in the registry? What are some of the things we've done? So we have version pinning. There's a package lock JSON. You could pin your versions. Many people choose to not use this feature, to not commit that file, but it gives you a lot of control because you're going to bring in those exact versions that you want. If you vetted something, this gives you that control. We also use sub-resource integrity within the registry. Here, it's not just something for client-side JavaScript. That gives us a feature-proof way of updating hashes as, say, SHA-1 or this becomes weak over time. We can upgrade those hashes. Of course, we added 2-factor authentication. It seems like table stakes, but we have it. 50% of the downloads are protected by 2FA. Really, really high-profile accounts have 2FA enabled, which is great. 6.98% of our maintainers have 2FA enabled. Which is a low number. I would like to see that higher, but we measure it, we monitor it, we're trying to get people to improve it. And we also have a feature called 2FA enforcement. If you're a maintainer of a package, you can require that all the people contributing to it or publishing have 2FA enabled. Of course, I'd like to see this become better. It's not that great with using CI systems because it's an OTP solution, but we do have it. Of course, credential stuffing protections, the Have I Been Pwned project is amazing. We've added that to sign up flow, to password change flow, to make sure you're not using just some garbage password. Pretty simple protection, but it constantly bats down passwords, and people have to pick better, stronger passwords, protecting those accounts. And this is one of my favorite, NPM audit. When we got acquired at Lyft and we took NSP and we brought it into NPM, we made security top of mind for 11 million users. All of a sudden, when you ran npm install, you got this message. Found 3, high severity or low severity or whatever. All of a sudden, they were hit with, what is this? And maybe they didn't know what to do, but they could run npm audit and find out more, or they could run npm audit fix and it would just auto bump versions anywhere down in the dependency tree if it could figure out how to resolve that, meeting those semver constraints. So all of a sudden, we have this attention of these developers, and we're giving them these sort of like security words and reports, and they're starting to ask questions, which is good because now they're engaged. They want, what is this regular expression denial of service thing? They go read, they get curious. Now all of a sudden they're leveling themselves up. We're also bringing communities together. We added a report a vulnerability button on all of the package pages, trying to engage with our community and the research community, giving them a place to send vulnerabilities. We triage every single one of them. We don't just pass it on to the maintainer and say, here's some garbage. We vet them. We look at the POC. If there's no POC, we write one. We make sure that we understand if it's a flaw or not, and then we talk to the maintainer and we talk to the reporter. And of course, sometimes projects go dead and they don't respond or they don't want to fix it. They don't understand. They don't want to accept a pull request. So the pull request, and we'll publish an advisory after 45 days. And what we see is once we publish those, we get community engagement. Hey, here's a pull request for this bug. Here's, how can we help? We also do token revocation. So if you accidentally publish your token to NPM, we revoke them. This is since, January, we revoked 92 tokens. It's not significant, but maybe those were really high profile tokens for accounts. I don't know, we just bat them down in email and say, hey, we watched somebody fight this bot 6 times. They'd publish a token, it would swat it down, publish a token, swat it down. It was amusing, but their account was being protected. And also we're kicking off things with the GitHub security team to start trolling through GitHub just like Slack is doing for NPM tokens to revoke them as they get published, because it's also a common source of sort of account takeover. Package signing is one that I'm sure has shown up, thank you, Jim, has shown up in the questions already, if it hasn't, because that's something that gets yelled at me all the time because it will fix everything, right? It fixes, well, NPM can't tamper with it, so it fixes insider threats and all this stuff. And we're doing some signing at this point, only internally. So we sign the integrity hashes and some of the metadata in the package with our Keybase key. We don't have the verification tooling yet, but we do have a manual way that you can do that. So it's not there yet. And there's some very sort of sticky things when it comes to package signing. However, my approach to it is going to be to get, to put out sort of a call for, here's the design, and get people engaged from the community that are much smarter than myself and my team to try to figure out how we can do this and provide the guarantees that you as a community sort of want. And see if we can do it right. And we might not be able to get all those guarantees, but we're gonna do better in this area. And then it comes down to something that I think is extremely fun, and I made this slide intentionally vague because we don't want to give up all the secrets quite yet. I did an experiment a few years back where I took all the packages in the registry that had install scripts, and I dumped them into an instrumented container, and I cataloged all the system calls that were going on for those, doing runtime analysis on install. It turned out 144 vulnerabilities for me, mostly modules that were downloading binary components or source code and using them as part of their build process, but weren't verifying their integrity. So if you, and it found one really interesting bug in Atom, which was just a HTTPS to HTTP redirect. And if you looked at it, ocular grep, you reviewed the code, yeah, they're using HTTPS, but it happened to just be that one network call that just wouldn't got caught. So we're doing some really interesting things with runtime analysis, and we're trying to figure out how to get that data to users. Things like, does this module talk to pastebin when you install it or run it or require it? That's a flag, right? And so if you're interested in this stuff and you have some thoughts around it, or you want to just, find out what we're doing, talk to me after and I'll go in a little bit more detail. Or pick your brain as to what you might like and how this tooling could help you. So, all right, we talked about everything up to the future, and now we get into the future and things that I'd like to do, and I really think this comes down to better tooling. When I hear about all of the sort of complaints around ecosystem, it's all about if you move too slow, you have the risk of known vulnerabilities in your stack, right? If you move too fast, you have the risk of malware. It's still probably a good idea to keep up to date, but like if you move too fast, if you kind of you have the risk of malware. So it's moving at the right speed with the right data to make the right decisions. This was our survey, and users are telling us that our tooling sucks, that we need better tooling in this space. They're not satisfied. This is, I don't remember what the question was, but basically, are you satisfied with your tools? Yes or no? They're not. So I think that we need to make things in the ecosystem more transparent. Between version X and Y, did maintainers change? Was there an anomalous publish? You started publishing from a different country. Like, what are some of those things without giving up privacy? Can we give you in tooling to make better decisions, or reporting is to just automatically give you that bill of materials, so you know what things got installed where at your enterprise. This one is a big one. You know that whole thing about open source maintainers being volunteers? We need to better capture the community enterprise efforts. You've got Microsoft doing these massive efforts to audit things, and we hear about 14, 16 bugs. We don't get the attestation of all of the things that they said was good, right? We looked at these things and we lose that effort. Nobody hears about that. The Uber team's doing great things. Dropbox, Netflix, PayPal, all these companies they're using JavaScript. They're auditing these things. They're auditing things internally, but we're not hearing about it. The community's not benefiting from it. And so just like, sending a pull request forward, we need to figure out a way, and I'm sure, we're going to have legal challenges and paperwork and all kinds of stuff. We need to figure out a way to capture that effort. And I don't know how to do that yet, but I'm really interested in this topic, and if you're interested in it, find me at lunch, find me afterwards, let's have a conversation and figure out how we can capture the efforts that you're doing so that it can raise the confidence in the community instead of just open source being this big scary thing. And that's all I have. I've got security wombat stickers if you want after, and that's me. Thank you. Let's see. What role does NPM as a company take in assuring security in the many libraries that it manages? Well, just like that one slide, lots of code review, that's what we do. We do static analysis. We've got a project called ESLint Plugin Security. It does AST analysis. It's just a handful of rules that we use that we developed at Lyft for pen testing. And then the security team, which is 4 people, we do a lot of that security review. And then we also pin versions. So we move fairly slow, right? We upgrade intentfully. I don't know how to use this thing. Boop. Okay. If NPM knows a lib has a massive vulnerability, then why do they keep delivering it to developers? Just because it has a massive vulnerability doesn't mean that it's exploitable, right? Doesn't mean that function call is being called, doesn't mean you're using it in the way that is exploitable, and so that's why we do it. But we do give you that report so that you know about it. Hey, you're using this particular version, so that's that. Kodo says, how are you scanning for malware? How can signatures look for dynamic nature of JS? Static analysis in JS, I think, is absolutely impossible, but you got to try. So we are doing runtime hybrid analysis. So we're trying to get better static analysis going. We're doing instrumentation of sandboxes and combined with static analysis to get more coverage. Boop. Are you familiar with node security roadmap.fyi? Yes, I actually reviewed an early version of that, and I think that it's a great effort. It's something that anybody doing security in Node in JavaScript should read because it calls out a lot of the threats, a lot of things that you need to worry about. So yeah, that's node security or nodesec roadmap.fyi in case anybody else is interested. doesn't the registry maintain only one package with a particular hash can be published for a version and any changes require a new version? Yes, you cannot delete. So the registry is immutable except for our security team and our support team. We have the power to remove packages from the registry. So you can't, well, there's a 3-day window that you can unpublish something. If you publish some source code that you didn't want to, you can pull it down. So yeah, it's immutable. You can't delete a package once you published it because, especially if somebody depends on it. That's the whole left pad incident where somebody sort of ganks a package out of the registry and breaks everyone's builds just because they got, just because they're upset for whatever reason. And you can't publish over top, so you can't change that. So you do have to publish a new version if you come on as a maintainer. We've been considering making maintainership a breaking change. So if you transfer a package, if I give you one of my package, you can only publish on a new major version. There's a lot of pushback from developers on that though, because of how, I don't know, it creates friction. And we're all about trying to keep the friction down with our tooling, but make things safe. So it's a balance. That's it. Thank you.